So in manufacturing, there's kind of two different approaches. And I am pretty much overgeneralizing right here. One is additive and one is I'm going to call negative manufacturing. So additive manufacturing is when you add stuff together and you build something up. Negative manufacturing, as I define it, is when you take stuff away. So you carve something out of like a solid block of wood or steel, or you burn it off or cut it out or drill through it. You're removing stuff. Now 3D printing is usually pretty much in the solid realm of additive manufacturing. I think most people can agree on that. I want to promote ideas of using a system that has a combination of negative manufacturing and 3D printing in the same device, and it's continuous and you don't switch out parts, and why that might actually be a good idea. So the first thing I want to point out is that it might allow for heat sinks and stuff to be built into the device that carry the heat as we're printing, which might lead to more precise manufacturing of plastics or stuff, because the heat doesn't impact the rest of the area as much, and we melt something on structures or weaken them so they collapse more. Or it can even, instead of a heat sink, which more just captures the heat by absorbing the heat and radiating out, where some heat sinks also radiate the heat out to like the air, you have just insulating stuff that you add insulation, then you take away insulation. Beyond heat sinks, you could also have vibrational sinks and more. This also could make the idea I've had before about, I talked about by combining metal 3D printing and plastic 3D printing and other 3D printing more durable even when there's a large temperature difference for the melting points. Beyond that, we can add something called support structures. And adding support structures might help support a really big piece or a delicate piece and make more complex geometries. Then you chip away at the support structures as you're making the piece so you can get back into certain areas, or so it doesn't disrupt certain areas, or so it just saves time, because you could save time because instead of having to chip away, move to a place and later chip away them, as you're moving your head to 3D print a new area, you chip away at some of the support right there and then. So you're chipping away at the same time you're adding stuff to just save a bunch of time. Another idea is more from the manufacturing standpoint, and that is you can make a lot of stuff first and then modify it later. And that might mean if you could negatively take stuff away. Now that actually might be two different devices, but the whole idea there is then you can have these items ship out faster or quicker because they're already somewhat pre-made, not fully pre-made. And you could also negatively manufacture something and 3D print additional features on top of that. So you could go both ways, depending on what's faster and more easily done for that specific case scenario. Or you could use this for repairs, where you put in something in 3D printing and chip away the bad parts, and you 3D print stuff to fix up the thing. A lot of possibilities right there. Another idea is to just make it so that people can customize it as needed. So and this could be the same kind of idea as the larger design, but where we start 3D printing a template or something like that, and later on we use the negative manufacturing techniques as we figure out, hey, we need to change this up slightly in some way due to feedback, user feedback or testing or something. Or we do it in real time when we start already 3D printing it, then someone tells us, hey, can you please change this up? In some ways, we might be able to also use this to recycle stuff better by using negative manufacturing techniques to take stuff apart while we're 3D printing. Or we can use this to add new stuff with a 3D printing part to make it last longer, or not recycle it, but turn it into a different item. So another use is that this might actually allow for more precise and accurate printing, because different negative manufacturing sometimes is more precise and sometimes additive manufacturing is more precise. It depends on a lot of specific circumstances, but also they could be more precise together, because you can have it work on different features that each one works better, but also you could add a certain amount of material into roughly this right shape, then just modify with negative manufacturing. And that added material already, because it's working from a better rough baseline, it becomes more precise. Or that you have it working in slightly different scales, so like they're offset by half of the maximum resolution, half a maximum resolution, and what you end up getting is they can work at a resolution like half the size. So that's just some examples. So another thing is, if you have negative manufacturing techniques, you could actually just add whole big chunks of stuff to it, and it 3D prints around those chunks, and then also carves out those chunks at the same time. So if you already have a base thing to work as a mold, you can work with more molds like a metal that you CNC milling. You put that metal chunk in, and then it's also 3D printing around it at the same time to save time and energy. The dust or other chemicals made by negative manufacturing, maybe you can take them away and use them to 3D print later on by remelting and reusing them, saving waste, and actually making this a lot more environmentally friendly than you would expect. This also might be very, very good for helping train AI to do a bunch of these tasks, because to some extent the movements of moving both machines are similar, and that's a very hard problem to solve mathematically, the ideal movement. But now you're trying to solve it for two different processes simultaneously, which might make for machine learning, actually makes machine learning more computationally easier, and it can actually speed up the task by sharing, by looking at the, because it's machine learning, sometimes neural networks, train better when you have bigger data sets. And you have a bigger data set because you're using the data from two problems to optimize that are overlapping. And you can also give it more different perspectives, kind of, is one way to humanize it and think about it. And it means that also each task, you don't have to optimize one thing and another thing, which saves time. And because you're optimizing them together, so if you run it for the same length, it works better. And you can figure out how to parallelize it better. Another thing is that combining technologies very much promotes the development of both technologies more together and stuff, and figures out how you might also combine parts to work better, such as the motor system, or the anti-vibration system, or cooling system, or heating system, or the algorithms might be promoted to have more ideas because they both work for both systems. It also really could save a bunch of time, because now you have a system that is really doing both things at the same time. So you can move the CNC machine that's doing stuff, or drilling on something and moving stuff, at the same time you're moving the 3D printer head, and so on and so on. So it could save time, or it doesn't have to go from one machine to another machine. And also when it's going from one machine to another machine, it could get damaged in a variety of ways. Another thing that is that because there's less transfer and these machines have more parts that are bigger, they're working together, there's ways you could actually reduce vibrations for higher accuracies. Now, that is something that's a very case-by-case basis you would have to figure out. And maybe tools for 3D printing or for negative manufacturing could be made better by either one and could be attached better. Well, thank you very much for listening. Please like and subscribe. It will help turn it out. I'm trying to reach 1,000 subscribers in a year, and 4,000 watts hours, which is really hard to help I think into it. Also, if you have any ideas for future videos, comments, or suggestions, please leave in the comment section below. Again, thank you very much. Goodbye.